All right, Algebra B students, we are going to get going with our first section of notes for Chapter 6. So we're looking at 6.1, Day 1. We're going to kind of go over the basics of standard form and hopefully explain a couple of the same things that you recognized in the Chapter 6 intro from Tuesday's lesson. Okay, so we do start with some vocabulary to copy down first. So the first thing we want to talk about is a parabola. A parabola we are going to define as the U-shaped graph of a quadratic equation. Okay. With the parabola, then, we have something called the axis of symmetry. The axis of symmetry is going to be a vertical line passing through the vertex of a parabola. It is also sometimes called the line of symmetry. We'll start to see that it's going to be the line that goes straight through the center of your parabola so that it's kind of equal on both sides. Last thing I want you to add for this one is that it's going to always be in the form of x equals, because it's going to be a vertical line, and that x value has to also be the x coordinate of the vertex. Okay, so as we find this, we're going to have a parabola. It's going to have a vertical line down the center of it called the axis of symmetry, and it has to go through the x coordinate of your vertex. So vertex. Vertex is the point at which the parabola makes its sharpest turn, or we're going to say it's the highest or lowest point of the parabola. It has to be on the axis of symmetry. And another kind of words that we use to describe it would be a max or a min. So we use those to help kind of describe what our parabola looks like. The last way we kind of talk about a parabola is just deciding which way it opens. So if it opens up or opens down. So I'm going to give kind of an example here. So a parabola that opens up will look something like this. Anytime that happens, that means that our a coefficient is going to be positive. This also means that your vertex, which would be down here at the bottom of your parabola, is going to be referred to as a minimum. Okay, that's compared to the idea of a parabola opening down. If a parabola opens down, then we know the a coefficient is negative. And we would say that the vertex up here is called a maximum. Okay, so a little bit of vocab to just kind of go through what each of these parts are called. All right, then we're going to graph our most basic quadratic that we can. So our most basic quadratic, slide this up a bit. Our most basic quadratic is just y equals x squared. So we're always going to be comparing these to the general form that we've already talked about this year, ax squared plus bx plus c. Today we're only going to look at just this first part. Okay, just the y equals ax squared. So I'm going to use my table down here to help. Slide that out of the way. So if I'm really saying I just want to substitute -3 in, so we're really just doing -3 squared, and -3 times -3 gives me a +9. Then I'm doing -2 squared. -2 squared is a +4. -1 squared is a 1, and we'll keep going. 0 squared is 0. 1 squared is 1 times 1, so that's a +1. And then we start to see our pattern repeat here. 2 squared is also a +4. 3 squared would be +9. 4 squared is +16, and 5 squared is +25. So if I graph this, I'm only going to graph the ones that actually fit. So I'm going to go -3 all the way up to 9. Then I have -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. So a couple vocab things to take a look at. First is that idea of a axis of symmetry. You should see that if I draw on this vertical green line here, it's going to go through the center. It's going to go through the center and through our vertex. That cuts this parabola in half. So you should see the symmetry between these points. The left of the line and to the right of the line, they should be the same distance away, and they're at the same height on the y-axis. Okay, so I'm going to go ahead and make this my parabola. Okay, so this is the equation y equals just 1x squared. And we call this is kind of like what we call our parent function. Okay, here's what that means. It means every other parabola is going to be somehow transformed from this one. Okay, so we use words as transformations as that it could be flipped, it could be stretched, or it could be shifted. Okay, those are kind of the different ways that we talk about how things are transformed. But this is always kind of going to be what we compare it back to. This is our most basic general. The last vocab word I just want to touch on is vertex. So in this here, this would be our vertex in this example, and we list our vertexes in ordered pairs. So in this case, it'd be at 0, 0. Notice in our table, right, our vertex right here, that's where we start to see that this symmetry happens. So the 1s match up, the 4s match up, and the 9s matched up. Okay, let's take a look at a transformation of the parent function. So now I'm going to take a look at 2x squared. You should already have our x values filled in. We're just going to go from -2 to 2, so don't worry about if there's extras. We're just going to go from -2 to 2. So this is really saying I want to do 2 times -2 squared. So order of operations says I have to square it first. So -2 squared is 4, and then I'm going to multiply it by 2. So this really gives me an answer of 8. Then I'm going to do -2 times -1 squared. Well, again, I have to do this first, exponents first. -1 squared is 1. 2 times 1 really gives me 2. And we keep going. So this would be 2 times 0 squared. 0 squared is 0. 0 times anything is 0. Then I have 2 times 1 squared. 1 squared is 1. 1 times 2 gives me 2. And we start to see the pattern. Okay, just to finish this one out, if I did 2 times 2 squared, that would really be 2 times 4, which gives me 8 again. Okay, so I'm going to come over here and I'm going to graph that. So I have -2, 8. -1, 2, 0, 0, 1, 2, and 2, 8. Do my best to make this a parabola on my writing pad here. Whoops, missed. We'll try that side again. A little better there. Okay. So as we look at our parabola here, a couple vocab words to kind of pick out. So first, that axis of symmetry again would be right down the middle here. So on this example, we would have an axis of symmetry. This would be at the vertical line x equals 0, because this is 0 down here on your x-axis. Then we could talk about our vertex. Our vertex is still down here at 0, 0. And then if we try to describe this graph, okay, a couple things. Some characteristics is what we call them. So I'm going to put a little characteristics down here. So the first characteristic is that my parabola opens up. If it opens up, that means this vertex down here is a minimum. Okay. And then we also know that it's going to be stretched. Okay. If I compare it to my original parabola that we just graphed on the other page, right? If I compare it to y equals x squared, we can see that this blue one, y equals 2x squared, is much narrower. So if we were to talk about how it is stretched, we would say that it's narrower than the original, which would be y equals x squared. Okay, let's graph a couple more. On our third one, now we're doing y equals 0.25x squared. Again, we're just using our -2 to 2. So to plug these in, this is really saying like 0.25 times -2 squared. Well, -2 squared is going to be a positive 4. 4 times 0.25 is going to give me 1. Then I'm doing 0.25 times -1 squared. -1 squared is 1. 1 times 0.25 is going to keep me at 0.25. 0.25 times 0 squared, that's just going to get me 0. And then we start to see that these repeat. So 0.25 times 1 squared is going to be the same as -1 squared. And 0.25 times 2 squared would be the same as -2 squared. So I'm going to go ahead and graph these. So I have -2, 1, -1.25, still at 0, 0 for the vertex, 1, comma 0.25, and 2, comma 1. Okay, that is the parabola we get for y equals 0.25 x squared. If I go to compare this, so you don't need to draw this in, but if I go in and I compare this to that parent function again that we've talked about, okay, so like I said, we're always talking about how are these transformed from the original graph, right? So if I wanted to talk about some characteristics, if I want to describe this, the first thing I could say is that it opens up still, which means your vertex down there is going to be a min. But then we could also say that this is going to be wider than the original y equals x squared, okay? Because if you notice, our green parabola is going to be wider than the original one, okay? Some of our other vocab, this still has an axis of symmetry at the exact same spot, right? This axis of symmetry, this vertical line here, this is still at x equals 0. And your vertex down here is still at 0, 0. Okay, let's graph one more. Now we are looking at the graph of y equals negative 4x squared. This is really going to be negative 4 then times negative 2 squared. Well, negative 2 squared is going to be 4. 4 times negative 4 is negative 16. Then I'm doing negative 4 times negative 1 squared. Negative 1 squared is 1. 1 times negative 4 is negative 4. Negative 4 times 0 squared is going to keep me at 0. And then I have negative 4 times 1 squared. 1 times negative 4 is negative 4. And negative 4 times 2 squared takes me back to that negative 16. So we'll use this graph instead. And I'm going to kind of spread this out a little bit. I'm going to count by 2's on the y-axis. Okay, I'm not going to change the x at all, but I'm still going to count by 2's on the y. So I have negative 2 and then negative 16. So 2, 4, 6, 8, 10, 12, 14, 16. So negative 16 down here. Negative 1, negative 4, 0, 0, 1 at negative 4, and 2, negative 16. We can make our parabola. Okay, if we want to talk about some of these characteristics. Now we change this up a little bit. Now that we're saying this parabola is going to open down. If it opens down, that means this vertex up here is actually a max. And now we're going to talk about a couple things. So now I'm going to flip my original one as well. If I flipped to write y equals negative x squared, my graph would look something like this. So now this would be y equals negative x squared. And now we can kind of talk about how it is stretched according to this one. And so now we would also say that it's going to be narrower. And instead of the negative, we just leave it as y equals x squared, because the negative just means that it flipped upside down. Okay. Some vocab. Our vertex here is still at 0, 0. And our axis of symmetry, go right down the middle here. That is still also at x equals 0. So this last one, we really just notice that because of this negative sign, it opens down, meaning it has a max. And because of this 4, so if we ignore the negative, the 4 tells us it's going to be narrower. So let's summarize those points and talk about what that a value gives us. So in general, today we were just looking at equations in this form, y equals ax squared. And we're saying that if we take the absolute value, those are our absolute value symbols. If we're taking the absolute value of a, and you get a number bigger than 1, that means that the graph is going to be narrower. Then y equals 1x squared. Okay. If we take an absolute value of a and it equals 1, we write that it's going to be called the same as y equals x squared. And if you take the absolute value and you get a number less than 1, then we say the graph is going to be wider than y equals x squared. Okay, so here are some examples. Okay, you'll get a graph. It might say something like y equals negative 1/2 x squared, or you might see something that says like y equals 12x squared. Okay, and then behind it, it's going to look like this: wider, narrower, or the same as y equals x squared. That's kind of what your homework might look like. And we just need to circle the correct answer. Okay, so if I look at this, the negative really just tells us up or down. So you want to focus on just the number coefficient without the negative sign. That's why we take the absolute value. And 1/2 is going to be smaller than 1. So you would circle and you'd say this graph is going to be wider. Okay, then we come down here, we look at 12. It's already positive, so we don't have to worry about it. If I take that, that's greater than 1. So then we'd say this graph is narrower. Okay, you'll have a couple more of those to practice in your homework as well. Last couple things to summarize then. It says y equals x squared is always symmetric to x equals 0, or what we call the y-axis. For that same equation, y equals x squared, the vertex was always at 0, 0. And then we look at the a value to decide if it opens up or down. So if we know it opens up, we know a has to be positive, which means greater than 0. If it opens down, we know that the a value has to be negative, which we'll write as less than 0. So if you want to put that behind there to help, a is positive, it opens up. A is negative, it opens down.